Hello, everybody. Thank you for joining us today for a look back at 2025, the year in review with Mike Stonebraker and Andy Pavlo. Our agenda today includes a deep dive into how AI and data management are affecting each other. Today, some of the trends that are AI trends affecting data management and data management trends affecting AI. Part of that will also touch on how AI is being used to automate database operations. And then Andy Pavlo will take a look back at some of the industry happenings this year, some of the milestones, acquisitions, and company launch, new companies. Companies are no longer with us, companies that are acquired, and talk about how that's going to shape data management and software development in 2026 and on. And then we'll wrap up with a really interesting discussion about how AI is affecting computer science and changing the way it's taught, the way it's researched, and how that's affecting career paths for a lot of people in this event, right? And then we'll wrap up with probably about 10 minutes of Q&A. Okay. For those of you who are familiar with DBOS, you may know that at one time it stood for Database Operating System. The company began as a research project between MIT and Stanford, and it was really prompted by help that co-founder Matei Zaharia asked of Mike to help them with some durable distributed queuing for Databricks. And that led to a research project into a operating system built on top of a distributed database as a potential replacement to Linux, something that was much more sort of cloud native by default. Today, DBOS stands for Durable Backends that are observable and scalable. I had to retrofit that acronym. And if you're familiar with DBOS, it's an open source durable workflow orchestration library that really makes your applications, your backends, resilient to failure. Also makes them observable, and through easier queuing makes them easier to scale those workflows. And as one DBOS user put it really succinctly, DBOS makes it impossible to mess up, right? And it's one of the reasons why DBOS is so popular with a lot of the new AI application companies where they need their agentic AI workflows to work as intended, no matter what sort of situation goes sideways. And Mike will talk a little bit more about the relationship between durability and agentic AI in a moment. But that's DBOS. So if you're building software and you want it to make it error-proof and observable really easily, check out the DBOS open source libraries. Okay, so you may wonder why, if we're not a database, then why are we hosting a webinar on database R&D? And as you know, Mike Stonebraker, the inventor of Postgres, is the co-founder of DBOS, and we're also very good friends with Andy Pavlo at CMU, the inventor of Databaseology, and also the founder of So You Don't Have to, an AI, which is an AI powered database tuning service, and encourage you to check that out. And without further ado, let's jump into the agenda and hear from Andy and Mike. Our first topic is how is AI impacting data management, and how is data management impacting AI? And why don't we start with you, Mike?
Thanks, Andy. And hey, other Andy. And I just want to mention that I'm pretty sick and not at 100%. So, Andy P, you have to go easy on me. Uh, and so, Sam Madden a couple weeks ago characterized, Gen AI and large language models as the best thing since sliced bread. He didn't say it in those terms, but that was effectively what he meant. My point of view is much more muted. And so I'd like to just tell you my experience with using large language models And as I say, I'm interested in enterprise data. And so the obvious thing to ask is, well, maybe you can use a large language model to query a data warehouse. And there's been some public benchmarks in this area, Bird and Spider 2, that are reporting reasonably good results in the range of 60 to 90%. That is not my experience with real data warehouses. We tried, there's a subset of the MIT data warehouse, which has the, students and classes and faculty and courses and professors, all that sort of stuff in it. And we got real users. In fact, CSAIL, the lab I'm in at MIT, is a real user of this MIT data warehouse. We created some real user queries from real users. We figured out what the gold SQL was that corresponded to those queries. And so we had pairs of, text and gold SQL. And so we tried out various LLMs on the MIT data warehouse, and we got accuracy of 0, not low, 0. It couldn't do anything. So then we tried all the standard techniques, RAG, decomposing the queries into simpler pieces, adding in data from other sources, and we could nudge the accuracy up to about 20%. If we added in that we gave the LLM the actual table that they had to go, a table or tables that they had to go look at, it got to like 30%, but nowhere near ready for prime time. Now you might say, well, maybe that stuff is an outlier. We tried this on 7 different real data warehouses, and we got the same results every time. Now, some people have reported better results, but I'm pretty skeptical, and here's why. What are the characteristics of the MIT data warehouse that makes it difficult? Number one, this is not public data. There's no way for an LLM to look at this data because it's behind, it's behind all kinds of privacy stuff and security stuff. So not public data. Number two, MIT is pretty idiosyncratic. If you want to know, who majored in computer science in the last 2 years, that's not a query the MIT data warehouse can answer, because MIT doesn't use lingo like computer science. Computer science is actually course 6.2, which is what you need to use. So there's also J-term, which is a 1-month term in January. None of this you can expect an LLM to know anything about. The third problem is what I call semantic overlap. The MIT data warehouse is full of materialized views, database term, and they're there to increase performance of popular queries. But what the problem is it gives you multiple ways to solve any given query, often with slightly different semantics. Like some data is monthly, some data is weekly, and so forth. So semantic overlap. And then the fourth thing is complicated queries. These mostly are 3- and 4-way joins with aggregations in them. They're fairly complicated, and as a result, if your database has any of these 4 characteristics, which is not public, idiosyncratic, semantic overlap, and complicated queries, I'm not optimistic that we're gonna get anywhere using an LLM. So my point of view is actually somewhat different. The way to do text to SQL, well, first of all, the question you want to ask uh, in an enterprise setting is, I have an ERP system, I have a CRM system, I have a whole bunch of other systems, lots of text, and I want to query, like who is a supplier of stuff to me that's also a customer. And so this is requires querying data sources that are all private, and a mix of text uh, and SQL. So sort of the data lake problem. So uh, how are you going to solve the data lake problem? Well, to me, let me just give you, uh, you know, a simple example. So we have a student who's working with the city of Munich in Germany, uh, who's dealing with their tram department, uh, their transportation department. So there are all kinds of queries, like why is this green signal not longer at this particular intersection? Or what's the maximum speed allowed of a tram when it's going through an intersection that doesn't have a light on it? And there's half a dozen different data sources that the city of Munich has that can answer this question in theory. And so this is a standard data lake. So my point of view is the easiest way to do that is to wrap these data sources into a very small subset of SQL so that a user can tell you what he wants. So I'm a fan of having the top level of such a system be SQL oriented and not LLM oriented. So it's something I'm working on, and this may be an outlier, but it may not be. Maybe Bedrock, the recently released Amazon system, will help in this area. But I should just leave you with try the following query to your favorite LLM. The query is, how many MIT professors have a Wikipedia page? And so there are two problems with this query. One is the answer to who's an MIT professor is in the MIT data warehouse, all the stuff I've already talked about. And then the second problem is Wikipedia, which is a data source, and there's a lovely user interface to Wikipedia. You just type in somebody's name and you get their web page. Now, it turns out LLMs have recently started being able to do that. So, but I can easily give you a more complicated question that they can't answer. So my point of view is you want to put a wrapper around the MIT data warehouse that makes it simple enough that you can actually answer such question doing text to SQL or text to a small subset of SQL, and then you simply wrap the Wikipedia data source with a find, Andy Pavlo, or find whoever you want to find. And then you want to just do a join between those two systems. And you want to do iterative substitution because there are a lot more Wikipedia pages than there are professors, at MIT. So this becomes, in my opinion, a query optimization problem that query optimizers are best in addressing. So that's the direction I'm heading. And as I say, this should be taken with huge grains of salt. Number one, I'm only interested in enterprise data, and other people are interested in lots of other stuff. And I'm mostly interested in data that is inside a firewall and unavailable to LLMs. So my experience is a little bit muted. And in my opinion, LLMs work great on certain things and are probably not the right answer to everything. So with that, Andy Pavlo has a more optimistic view of the world, I think.
I would say also the Wikipedia article about me got taken down because I think the bio said I was born in the streets of Baltimore, which is like I was born in Baltimore, obviously not in the streets. So yeah, I'm way more optimistic about what LLMs are accomplishing. And again, in the case of natural language to SQL, for certain challenges and certain things, yeah, it's going to struggle with that. But I've been mostly interested in greenfield applications. You know, the future enterprise applications people are going to build have to start somewhere. They're starting now. Um, and you know, with the Andre Karpathy coining the term vibe coding in the last year, uh, you know, we're seeing this huge proliferation of people developing new applications that are written almost entirely by LLMs or these coding agents. Um, and you know, you say, oh, well, is that code going to be better or worse than what a human can write? It's about the same, right? Because it's being generated. These models are being trained on the giant corpus of all this code that's out there, and so humans write, sometimes good code, sometimes bad code. LLMs are going to do the same thing. Um, so I'm pretty bullish on what LLMs can do, at least as like coding agents. Um, just speaking from experience in our own course that we teach here at Carnegie Mellon, our projects are all in C++. A year ago, the LLMs could maybe solve some of them and not all of them. Like it would generate code, but not all that code was actually correct or useful. It's getting to the point now for our projects where they can be entirely written and solved by LLMs. So I think the vibe coding stuff is real, and I think we're going to see just way more database-backed applications going forward. Now the challenge is you have all these agents generating this new application code that are then going to interact and read and write, data in a database system. So now you have to handle all that slop that's coming at the database system. So the before LLMs, you'd have all this application code written by humans, and they would hit up a database system, and you were lucky if a human or DBA was available to actually, maintain and optimize and monitor these database systems. So now you have a human's not writing the code, and now you have no human actually monitoring the database system, and that's sort of a recipe for potential disaster. So on the research side for myself, we've been looking at for several years now the use of machine learning and AI technologies to automate the administration and optimization of these database systems, right? And it's not the idea of automated tools is not new, right? It's not this something that AI all of a sudden enables for us, right? People have been trying to do this going back to the 1970s. Some of the first work was being done on trying to automatically pick indexes in relational databases. Like one of the first papers is in Sigma in 1976. So people have been doing this for a long time. Microsoft Auto Admin Project was trying to do this as well. But what we've been working on is the ability to look at the database system holistically in terms of trying to tune everything you could possibly want to tune in a database system to account for the random queries showing up from these vibe coded applications, and also looking at the life cycle of the database system. And it turns out the LLMs are pretty good at this. I will say, though, well, I'll get to that in a second. But so one of the things that we've been looking at now is how to tune everything a database system exposes to you all at once. So there's a lot of work on how to tune, like what's the best indexes you need, or what's the best like knobs you need for the system. Think of like shared buffers in Postgres and the InnoDB buffer pool size in MySQL. But all these tools have been out there only sort of targeting one thing. And so we've been looking at how can you tune everything all at once, because that allows you to find the true like global maximum configuration for your database. And so we, in our latest work in this space, we're not using LLMs to make these decisions, but we're using LLMs to allow us to do knowledge transfer between different different types of database systems or different database deployments. So we can tune in a single algorithm, we can tune indexes and knobs and query plan hints and table level knobs, index level knobs, basically everything that Postgres exposes to you, we can tune that all together. But now you have to build, you're training these very specific models that are just for this one database instance. And our latest work is leveraging LLMs to identify databases that are sort of similar to each other, but not exactly the same. And we can take all the training data we've collected from tuning tuning this one database and apply the knowledge to this other database. And it works surprisingly well. And so the point I was going to make about the performance of these algorithms is, the current research shows that one of these bespoke customized algorithms that's dedicated or been built to do specifically database optimization and database tuning, it can do about 2 to 3x better than what an LLM can do. But the LLMs can do this pretty quickly. Like ChatGPT can spit something out in 15 minutes to tune your database, whereas our best algorithm can now take 50 minutes. So there's this trade-off between like how fast you want things done versus how good you want things to be. And so it's a combination of these things, depending on the severity of the issues and what you need, that you may want to choose one versus another. Now, the other cool thing we're looking at with LLMs, and why I'm very bullish on this, is the reasoning agents, the ability to identify issues or problems, and then identify what sub-agent or what tool you want to then invoke to how to solve it. So, if there's an anomaly detection, there's some kind of latency issue in your database system, the reasoning agent can then decide, oh, I want to run this tool because that's going to build my indexes because that's the problem I think I have right now. Or I want to run this other tool because that'll optimize my storage capabilities. And so that's the really cool thing that LMs, I think that what I think is going to come out in the next year or so is the ability to now start looking at a bunch of different problems simultaneously and deciding which subagent to call out to. And the subagent could be an LLM, it could be one of these bespoke algorithms. So I think that's pretty exciting. And I think LLMs are certainly a game changer in this space.
Okay. Well, I think my point of view is that at least in the data management world, I think auto tuning, should be successful, because it ought to work and it ought to be commercially viable. And so I'm enthusiastic that son of AutoTune is alive, even if AutoTune didn't make it.
I would say the challenge we faced with AutoTune, I think, was because we weren't hosting the database system, right? That we had this form factor issue where like someone had to then give us permissions to connect the database. And with AutoTune also too, it was passively tuning, meaning it was on the outside of the system trying to observe what happened and then make changes and then try to observe what happened later on. The new work we've been doing, since we're not trying to host the database system, but we're looking to integrate with one of these existing platforms that are out there now, is if you put a proxy in front of the application in the database server, think of like PG Bouncer, PG Cat, PG Dog, there's a bunch of these ones for Postgres and other systems. Now you can see the queries as they arrive, and you can actually start to manipulate them as they come in. And we're still not hosting the database system itself, but at least now we're seeing the effects of the changes that we make. And that has been something that we've been really, it's made a big difference in what we're able to do, whereas AutoTune couldn't do. So from a commercial side, the way we're approaching this now is rather than have a standalone product that someone has to sign up for, connect their database system, give us permissions and so forth, we're looking to do like, we're in discussions to do like OEM white label integrations with the existing platforms that are out there. And that just allows us to focus on the ML database side of things and less about the developer experience and onboarding process.
Yeah. So I guess anyway, best of luck to you, and I hope you succeed.
Thanks, Mike.
One thing I would like to talk about is the entire world is in love with agentic AI. And agentic AI means to me that you've got a workflow of stuff, and some of it is LLM, and some of it is AI, and some of it is whatever. And which is if an LLM can't do it directly, maybe you can put some stuff around it that will make it more successful. And we've been doing that a lot at MIT. And so one of the things that DBOS found out early on was that by and large, agentic AI applications wanted durable computing because a lot of this stuff is long running, and if you get an error, you don't want to redo everything. So durable computing is a big deal in agentic AI. There's a bunch of commercial products that do it. But so far, agentic AI is largely what I call read-only, which is you query a bunch of places, you put together, well, I predict Andy Pavlo is going to be successful with Son of Ottertune or whatever. So I think it will take very little time for agentic AI to become read-write. And what that means is that durable computing is basically the D in ACID in transaction systems. It's exactly the same thing. And the way everybody is approaching durability is using database techniques. You have a log and you figure out how to, if you get something bad happens, you rewind and then play forward. So it is a database issue. And the thing that's marvelous is that it requires you to put application state into the database. So as Andy Pavlo said earlier, gradually, I am pretty sure that the database is going to take over storing state for applications, because that way you get durability. But the minute you have read-write, so my favorite example is suppose you're running an online bicycle store. And here is a rough sketch of the server side to such a system. The client comes in and says, I want to buy an XYZ bicycle. So your first action is to say, well, do I have one? So you need to query inventory and then reserve it if you have it. And then secondly, if you have it, then you want to make sure you want to do business with this customer. And that can be an LLM to say, does this customer return too many stuff? Does he have a bad credit rating, et cetera, et cetera. If that's all okay, then the third thing you do is take his money. And that, is PayPal or whatever your favorite, system is. And if that's okay, then you ship the bicycle. So it's basically four steps, each of which is a transaction, and most of them are updates. So for example, if you give the fulfillment system a bad address, then it's got to unwind everything. So, and there are a bunch of updates in these various steps. So that's a case where there are updates. And if you just, you've got to deal with the failure scenario, and durability just deals with the forward scenario, meaning finish your workflow. You also have to deal with unwinding it. And that requires some notion of atomicity. And so I think it's a huge deal to figure out what ACID actually means for workflows. And I'm just touting a paper I wrote for CIDR that's going to appear in January, which I think has an interim solution, but I don't think is the final solution. So I think figuring this stuff all out is going to take a bit of time. The other thing is that the way LLMs are currently structured, most of them are non-deterministic. So if you have a bug in your code, chances are you won't be able to repeat the bug. And this is something database people have known about for years and years and years and years. These are called Heisenbugs, which are unreproducible, as opposed to war bugs, which are you can reproduce. Jim Gray, wrote a bunch of stuff about this eons and eons ago, and we're clearly going to revisit all of this. So I think this is a case where database technology is going to be wildly helpful in making agentic AI, acid plus or whatever it is that's going to mean. So that I think is going to be a huge deal. And I think the programming language stuff, I think it is already proven that it's very helpful. Vibe coding does work. It works best on green fields. Absolutely true. The problem is that 95% of enterprise programmers don't have a green field. And so then you've got to deal with what's there. And it's also well known that vibe coding does best if stuff is well structured. And the trouble is that's not true in a typical enterprise. The system gets updated, maintained, hacked, updated, maintained, hacked. And eventually it gets so ugly that you throw it away and rewrite it. So I think we have to change the way enterprises actually write software in order to take maximum advantage of vibe coding. So I think there's lots and lots of work to be done. And I'll shut up and turn it over to Andy, who's going to tell us about M&A.
Well, it's not just M&A. It was a wild year in databases. I feel like this year there was more activity than maybe the year before. Maybe we'll start off with like the major acquisitions. But the biggest one was Databricks bought Neon, and then soon after Snowflake bought Crunchy. So there's a lot of activity in the Postgres space. We'll talk about in a second. The IBM bought two database companies. They bought DataStax, the main company building out Cassandra, earlier this year, and then I think they announced this week that they bought the Confluent, the main company backing Kafka. So, that's those are pretty big plays in terms of funding rounds. There was ClickHouse, Supabase raised big rounds. Databricks raised another big round because they always do, waiting to go IPO. Informatica got bought by Salesforce. SkyDB got rebought by MariaDB, SkySQL got rebought by MariaDB, which is a weird one because they forked it off as a separate company, I think last year, and then they bought it back this year. The other big announcement was Fivetran is merging with DBT. So that's, I think, probably will get solidified or finished next year. So yeah, it was again a lot of activity in terms of database companies going under. I made a prediction that there'd be a lot of more companies failing in 2025, and there's some Gartner report from about 2 years ago that sort of surmised the same thing. With the only 2 or 3 companies I can think of that went under is Voltron Data announced that they were closing shop a few weeks ago. Fauna closed shop in May. There's a Chinese MySQL hosting company called MyScaleDB that went under early this year. So I was wrong about that. I thought that there'd be more database companies closing. A bunch of friends at database companies have been telling me it's actually been a really good year. So that's very positive. So again, I was wrong about more companies failing. Of course, some did, but not as many as I thought there was going to be. And maybe that's, some companies are barely hanging on, but who knows? There was 2 companies that went to private equity, Couchbase and SingleStore. SingleStore got bought by, I think the private equity called Vector, and they were the ones that bought MarkLogic a few years ago. So they have some experience in running database companies. But usually when private equity buys a company, they kind of get put into maintenance mode. So hopefully Couchbase and SingleStore can get past that. In terms of just the overall vibe of the year, I mean, obviously it was another banner year for Postgres. Obviously with Mike here, I like how in the beginning he's listed as the inventor of Postgres, and I'm listed as the inventor of like a meme term, databaseology. So certainly not the same, but I'll take it. And also we could have put the Turing Award too. That's more important. But yeah, no, there's a wild year for Postgres, right? Databricks bought Neon. They also bought Mooncake, which gives them capability to have Postgres read and write to Iceberg. Microsoft has put out HorizonDB. It's their hosted version of Postgres that has an architecture similar to Neon with disaggregated storage. They announced that I think 2 or 3 weeks ago. It's something they've been working on for a while. So it's just more and more Postgres. The only other potential competitor to Postgres, if you would call it that, in the open source database space was MySQL, but that ship has sailed. Plus, Oracle fired up basically the entire MySQL development team that wasn't working on HeatWave. They fired all of them back in like September. So there really isn't any major company, putting all the energy into building out MySQL. It's basically Postgres has won the space. So that's super exciting. The Postgres code base it's pretty, it's beautiful. It's a great front end. The back end is a little dicey, and I've written blog articles. We've reported this as well. The effort out of Supabase to integrate OrioleDB is pretty exciting because that's a modern implementation of multi-version code control and other things that Postgres. I mean, Mike, you guys did it in the 80s. There wasn't really systems to look at to say how to do this. So we're trying to write. Hopefully, they're going to right the wrongs of what you guys did back in Berkeley back in the 80s. So anyway, yeah. So the database that commercial space is super. It's super energetic now, and like I said, there's all these vibe coding applications being generated, and you need Postgres is sort of default choice for a lot of these things. One more thing also to mention too. There's 2 major efforts announced to make distributed Postgres. There's Multigress out of Supabase, and that's being led by the guy that invented Vitess at MySQL, and which was then commercialized as PlanetScale. And then PlanetScale also announced that they have a project called Neki, Neki, that's trying to sort of do a similar shared nothing version of Postgres. And what's really fascinating about this is this is not the first time people tried to make distributed versions of Postgres. There was a bunch of work in the late 2000s, early 2010s from companies like Translattice, GenieDB. I think Huawei had a project in this space, but no one's really successfully have done this again for OLTP workloads. And so I think there's enough energy now where the time is right where you actually can finally have a scale out distributed version of Postgres, either through Multigress or Neki. So that's one major thing that I'm looking forward to next year that I think will come out.
Well, while we're on the subject of Postgres, I think Postgres has and will continue to take over the world. And the reason is that all the major cloud vendors have bet the ranch on the Postgres user interface. And so the wire protocol is going to be omnipresent. And they've either, in all cases, they've either got to pick something to code to or do their own thing. And every single one of them has picked the Postgres wire protocol. And I think the reason that was a good choice was a whole bunch of years ago, Oracle bought MySQL, and that soured the community that this was going to be, anything that looked like a community. And the thing I find absolutely amazing about Postgres is that the system is not owned by any enterprise, that it's run by a collection of very, very bright folks who work for a variety of places. So you should think of Postgres as the way open source was supposed to be. It is by the community and for the community. I wanted to actually just talk about a couple other things. Number one, somebody mentioned Kumo in the chat. And yeah, we've looked at Kumo. Kumo does predictions. They don't do text to SQL. So it's not, they solve a different problem. The other thing is there are other uh, distributed Postgres-like things. Greenplum is one. Cockroach is another. In fact,
Yugabyte.
Yugabyte is another one. So, and also, uh, anyway, there's a couple more whose names escape me, but I think betting the ranch on Postgres is absolutely the correct thing to do today if you haven't done it already. The other thing I'd like to point out is that Andy and I wrote a paper a couple years ago called What Goes Around Comes Around and Around, something like that. All of you should go back and read that paper because, in my opinion, that is a fabulous predictor of what's going to happen. So just for example, there's a lot of interest in vector indexing or in vector databases. Well, what is a vector database? Well, a vector database is a bunch of blobs, relational style, with a graph-oriented index. And any of you who've read Frank McSherry's work, he clearly shows that the best way to do graph retrieval is encode the hell out of the graph, put it into main memory, and write a custom gigaw to do that. And the successful vector databases seem to be doing exactly that. So my point of view is go read that paper, which I think is very prescient as to what's going to happen.
Thanks. We'll get a link to that and share it with everybody, along with the recording of the event. Quick question on this before we turn to kind of the future of CS. You just mentioned vector databases. There were quite a few questions about the vector database segment, maybe for Andy. Just are there any vector databases you like more than others, and just kind of your thoughts on vector database space in general?
I gotta be careful with my words because I don't want to piss people off. I would say I like the Weaviate guys. I haven't used the system, but in terms of understanding what they're actually doing, because they're very open, it's open source, the documentation is well written. I can understand what they're doing more so maybe than the others. We've had all the vector database companies give talks with us that are on YouTube. The question for these vector database guys that they have to figure out, and this is something that I did talk with the Weaviate CEO a few years ago, was right now they're not being used as the databases of record, right? They're basically JSON, as Mike said, they're JSON blobs with these vector embeddings you put inside them, and they build the indexes for them. And so right now, a lot of people are treating them almost like an Elasticsearch, where there's it's the second copy of the database where you can run your nearest neighbor searches on those and not interfere with the data warehouse or the regular OLTP workload. So it's going to come to a point where they have to decide whether they want to remain as an Elasticsearch, where it's the database on the side that's very specialized, which is fine. There's a market for that. Or they want to start being the database of record. And at which point you have to start adding basically all the things now that a Postgres or a Cockroach or an Oracle in them would provide for you, like transactions, SQL support, so they'll have to decide how they want to approach that. And I would say that the challenge though is at the end of the day, the vector index it's an index. So it's with systems like Postgres and that are highly extensible, you can add these new index types fairly quickly. And it was notable that when the when ChatGPT sort of became mainstream in like 2022, 2023-ish, and then RAG was sort of the buzzword everyone was using, and they realized, oh, how do you do that? You need a vector index. All the major database players added vector indexes within a year. I mean, there was open source, a lot of them are leveraging open source tools or open source libraries like DiskANN or FAST from Meta, but it wasn't a big lift to go add these things. Versus like when the column store stuff came around, that's a pretty fundamental engineering change you have to make your systems to support vectorized execution or column store stuff. Whereas with the vector indexes, you could plop in one and get it up and running fairly quickly. So to me, that shows that the moat for the vector database systems, the specialized systems, is not that wide. And certainly they're going to do things a lot better than like a PG vector Postgres one, for example. But like for 99% of people, that's probably good enough to use something like PG vector.
Well, two other quick comments.
Yep.
One is fancy vector indexes basically are limited to main memory. So if you got a problem that doesn't fit in main memory, your performance is going to fall off a cliff. And the second thing is, if there are a lot of updates to your vectors, it's a hellacious problem to update the indexes, just hellacious. And so if you to the extent that you have read-only small data, I think the vector indexes are just fine. But if you have a bunch of updates, then I think it becomes a much more complicated problem. And you actually, if you run the indexes in the same system of record as the data, then at least you can keep it consistent. So, end of speech.
I mean, not like super consistent, right? Because then like you can't do like sometimes some of these indexes you got to rerun the clustering algorithm, right? And that's how you got to rescan everything all over again. It's the same challenge. It's the same challenge as the inverted indexes. So they might have a sort of side buffer where you absorb all the writes, and then eventually you got to run the more expensive rebuild job.
One other question about the market. Andy, you mentioned that Voltron shut down. There was a question about what that might say about the future of GPU accelerated databases.
Yeah, okay. I gotta be careful here. So I would say I have been skeptical about GPU databases for a long time. In 2018, we had a seminar series where you invited all the major GPU database vendors come to campus. And I just remember that they would tout all these amazing numbers, but they were only for databases that could fit in the memory of the GPU. And they would always beat up on Greenplum for some reason. Like who cares about Greenplum in like 2018? So I was skeptical at the time because it seemed like a very niche, like your database has to be small to fit in the GPU. What had changed and what Voltron showed in their Theseus project or Theseus system, although it didn't have product market fit or viability as a product, they showed that like how to stream the data fast from disk into the GPU and have it treat the GPU as like an accelerator to the overall database system without having to load everything in. So to me, that's the game changer. And without naming names, I would expect you should expect to see some pretty big announcements in 2026 for major database vendors saying that they now support GPU acceleration.
Cool. And one more on the market. How is the acquisition of DataStax, Couchbase, Cassandra, and Confluent, Kafka, and Flink kind of changing IBM's position in the database market?
Oh, Mike was CEO of or CTO of Informix. He can tell you about IBM as well, right? I mean, DB2 still makes a lot of money. IMS is probably still the milk and the maintenance fees. They still make a ton of money, all these things. The IBM today is not the IBM of the IMS days, right? Certainly the culture and what they put out change. So I think that it remains to be seen, right? So it remains to be seen whether how much they're going to be deeply involved in the day-to-day operations of DataStax and Confluent versus like in like a Red Hat style, like, let them do their own thing almost as a satellite, or whether, how quickly they'll be integrated and part of like the overall consultancy stack of whatever IBM puts out there now. These cases for Cassandra, I think the number 2 contributor to Cassandra source code is actually Apple. Apple runs one of the largest, if not the largest, Cassandra cluster in the world. That's public. So I think Cassandra, the stewardship of Cassandra, I think will be fine. With Kafka, that remains to be seen. So, but again, I can't. The Jay at Confluent is a smart dude. I'm sure they'll figure something out.
Well, I think the thing you should all remember is that IBM is basically a services company and a custom software development organization. And so what's clearly happening is IBM customers have been asking for these two systems. And so IBM has enough throw weight to just buy them. But I think, IBM has a legacy hardware business and a monumental legacy software business. And they are going to continue to milk that until everyone on this call is safely retired.
Thank you. All right, let's change topic a little bit and talk about computer science and how AI is impacting curriculums, MIT, CMU, and elsewhere, and career opportunities. In fact, somebody's already asked on the Q&A box, what skills are required to get a job at a DBMS company. But maybe you guys Andy, you can start by talking about how AI has impacted the curriculum.
Yeah, I would say right now, nobody knows the answer, right? The LLMs are amazingly good at answering exam questions, homework problems, right? Anecdotally, I would say in our intro database systems class, the first homework assignment is we give you a data set, we give you questions. It's kind of trying to solve the same problem Mike just talked about. And you have to write the SQL to answer the question. And we're fairly confident most of the students are using LLMs, and in fact, honestly, I say at the beginning of the semester, we encourage them to use LLMs. Like it's a tool that should be used by any developer now, like GDB or other debugging tools. It's the way the world is. But I will say though, at the end of the day, you have to understand the fundamentals, and this is something where here at Carnegie Mellon, we're placing a stronger emphasis on. We've always been very good at it, but now more than ever, where it goes back to the vibe coding stuff. You can have LLMs generate a bunch of code, but if you don't understand the fundamentals of what this code is trying to do or what you're trying to achieve, then you're going to be lost. And so so I say that the things you should be learning are the core fundamentals of computer science, and that part really hasn't changed. It doesn't matter what, like, if it's in JavaScript, it's in C++ or Rust or whatever. Like the language and the tooling may change, but the fundamentals matter, and being aware of what what software is trying to do for you. In terms of answering the question of what skills you would need to get a job at a database system company these days, again, I don't think it has changed too much yet. Understanding system fundamentals, understanding a little bit what the hardware does. The great thing about databases is you have to understand kind of everything. You touch everything, so you have to understand what the hardware wants to do, the OS wants to do or not do for you, what the network wants to do for you. And so understanding all these things, and then I would place a strong emphasis in the ability to interact and manipulate and understand large code bases that you didn't write. Again, LLMs are helpful at these things, and also debugging, because that problem doesn't go away, and LLMs can't solve that yet. I think they'll eventually get there, but understanding how complex components fit together, interacting with each other to identify bugs, identify race conditions and other issues, that problem doesn't go away. And those are the kind of things you just have to get through practice. And this can be done through a variety of ways. So I would say that the resources are significantly better than certainly when Mike was a student and certainly when I was a student. There's so many things now that can help people come to terms and understand what data systems are trying to do. It's just a matter of doing it.
I think as long as you come from a first-rate, university, majoring CS will be just fine because it's exactly what Andy said. You'll be taught how to be productive utilizing all the tools that are available. I think the market will be pretty terrible if you graduate from Control Data Institute or those kind of places, because then you're just taught to code, and that's not going to be a very marketable skill unless you're super, super, super smart. So I think chances are the total enrollment in CS at major universities will be flat to down for a while, and after that, I have no idea what's going to happen.
But I would say also too, like in one hand, yes, like it's gonna be harder to get jobs because AI helps a lot of things. But then going back to the vibe coding piece, like it's so much easier now to build stuff, right? So you don't have to. The end goal shouldn't necessarily be to go work at Google or Apple or whoever. Like you just go do your own thing. And again, I realize that's easier said than done for a lot of people, given different financial situations. But like that part is also exciting too. That like the barrier to entry is significantly reduced. But again, like I would say you still need to understand the fundamentals.
There was a question related to the fundamentals. A few of them actually. People were asking, what are the what do you think are the most important fundamental database internal concepts somebody should learn or master, to improve their career opportunities?
I mean, one is not, I can pitch my own thing. Like, we put all our course materials online on YouTube, and you can do all the programming assignments, you can do all the homeworks. You don't have to pay CMU any money. So it's all there. By all means, dive in, go for it. I mean, I would say it's kind of the acid piece, right? Atomicity, consistency, isolation, durability. I mean, that's for transactional things, but understanding like just what that looks like, how you move data from non-volatile storage into memory and interact with things. How do you make sure that people can access their data and not lose anything? So those are sort of the high level fundamentals. And as a part of that, like you got to understand algorithm complexity, you have to understand data structures, you have to understand optimization techniques, you have to understand concurrency control, a little bit of set theory for relational algebra stuff is always good too as well. Like I would call those the fundamentals. And then as I was saying before, the great thing about database systems is like whatever you're interested in the context of computing, you can do it in the context of databases. So if you like algorithms, there's a lot of work in that space you can look at. If you like networking, you can do that. You like PL, there's a bunch of attempts to make SQL better or change SQL. So like whatever you're interested in, you can do it in the context of databases, and oftentimes people pay you a lot of money for it. So that's why I'm pretty bullish about things now.
Cool. We're at the top of the hour, so one more question. This came from somebody who in the registration form, but the question was for each of you: why did you choose to become a DBMS researcher?
Mike, you can talk about the draft story.
Well, the simple answer is, I went to graduate school only because I was subject to the draft way back then, and my choice was to go to Canada, go to jail, go to Vietnam, or go to graduate school, and that made things really simple. And once I was in graduate school, I managed to stay there till I was 26, and the Army didn't want me anymore. So then when I got a job, my thesis, by the way, I think is totally ridiculous. And when I got to Berkeley, I said, well, I have to have some way of getting tenure and pick a new something to work on. And the thing I found absolutely, made an astronomical difference was Berkeley gave me a mentor who was Gene Wong. And Gene said, Ted Codd just wrote this pioneering paper. This is in 1971. His paper appeared in CACM in 1970. So we started looking at data stuff. And Ted Codd's stuff was easy, simple. You could understand it. It had some mathematical underpinning. The other proposal was from the Committee on Data System Languages, CODASIL, which was this low-level graph structured thing. There was a total mess, and Gene and I looked at each other and said, how can anything this complicated be the right thing to do? So that sort of set the path. And a lot of it was happenstance, but a lot of it was getting a mentor when you land at whatever university you're going to try and get tenure at.
So Mike's story is a bit more prolific. In my case, I was arrested in high school, and I didn't want to go to prison, and so I looked at the Federal Bureau of Prisons statistical information about what is the lowest population of type of Americans that are not in prison. What's the lowest population of people that are in prison? And it was people that had PhDs. So I figured if I get a PhD, I'm less likely to go to jail or prison. So that's why I decided to pursue that. And then databases just sort of came naturally to me. I worked at a shady startup, and we switched over to MySQL, and I learned a relational model when I was in high school. It was awesome.
And you should talk about the time you actually did go to jail.
Hold on. When I was arrested, we pled guilty to local charges and didn't go federal. So I never went to prison or jail. When I did try to propose to my wife in prison, they never actually put me in jail, Mike, because they were concerned that once you get in jail, then I'm under their insurance. So if I got in trouble or got hurt, they would get fired. So I was outside in the holding area.
Okay, not the answers I was expecting, but excellent. All right, so I think we're going to have to wrap up now. I'm sorry we couldn't get to every question, and want to thank Mike and Andy and Chen from DBOS for helping out with the webinar today and sharing your wisdom and experience. And want to wish you guys and everybody online a great holiday season, Happy New Year, and look forward to seeing you on an event in 2026.